Hi guys, welcome to today's tutorial. Today I'll be walking you through this tool that basically assesses the topographical accessibility of pedestrian movement throughout urban spaces. So this is Pedestrian Catch, or Catch as we like to shorten it. And basically once we open up the application, we can see that all of our settings are located here in the top left-hand corner. So to get started, let's type in our location. So I'm going to type in Hawthorne, as that's where my university is located, and I'm interested to see what the movement around the campus is. And from there, we can see that we are given this little node here, which we can actually drag and drop around wherever we want. In this case, I might just drop it here at the train station. Now we can also add some additional nodes. So let's add two little additional nodes that can further assess the area. So let's put this one perhaps on the other side of the campus, and maybe we'll put one over here to see where people move, and if university is the place for everybody to be navigating towards, or whether there's a park or something else, or the shops down Glenferrie Road that are more popular and accessible. And we can also then change the speed limit here. So we can set the speed up here. Faster speed obviously could represent slow moving cars or bicycles or even some runners. I think that this is a pretty good standard to keep it at for walking pace. However, we might make it a little bit faster. There might be some people running to class around campus, who knows. We also have the ability here to change the time for which people are moving or walking. So in this case here, we're going to set it to 15 minutes, I think is a good standard. People probably don't tend to be walking much further than, for much longer than 15 minutes. Seems a little impractical in a lot of scenarios, especially if they've got a heavy school bag or work bag, etc. And we'll keep that all the same. All of these settings here look pretty good to get started with our simulation. And so to do so, we just quickly hit the start button and wait for the simulation to then run. As we can see, the node's starting to show the movement through these little arrows. We can see that there's quite a lot of movement already happening around the campus. It just seems to stop there. I guess a lot of people are going from the train station to Swinburne, and that's probably as far as they're travelling. Perfect, that looks like it's all run quite smoothly. As we can see here, this ring showcasing the extent of the data tracked, and out here we can see this is our 15-minute marker ring. The closer in we get, the less time people have been moving for. So let's zoom back in and have a look at what's the data that we've kind of can see from this surface level already. We can see that, as I just mentioned earlier, there is quite a fair bit of congregation around the campus, and it seems to be the main place people are travelling, alongside a little bit of movement here around Glenferrie Road as well, and perhaps around these parks as well. Seems to be quite accessible for pedestrians. Now, from this, we can then take data and say, well, why aren't people moving to these areas, or what's making the university so popular? And then we can start to create some design solutions for that. We also have the ability to then download this data and use that to apply it to another mapping application and map our data in a very clean, aesthetic way, or extract different parts of the data that we want to show. Basically, that's an overview of Catch. It's quite an easy app to use, quite self-explanatory, and it's a really great tool to help you understand the accessibility of pedestrian movement in urban spaces. That concludes this video about Pet Catch, and I'll see you in the next tutorial.